Hello and welcome to the last video on the nth term of linear sequences. Now, a question you might ask yourself is, if you have two sequences, do they ever have the same number in the same position? So here I've got the sequence 2n plus 11 and 4n plus 3. Is there any point in those sequences where they've got exactly the same number in exactly the same position? Now I'm going to do this the slow way first, just so it's very clear in terms of what I mean by that. So 2n plus 11, if I add 1, sorry, if I substitute in 1 for this, that's 2 times 1 add 11. My first term is going to be 15, and then, 13, and then 15, 17, 19, 21, blah, 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 blah. Keeps on going forever. 4n plus 3, I could substitute in substitute in 1 would give me 7. Substitute in 2 would give me 11, 15, 19, 23, and so on. Now, we can see that both of these sequences have the number 15 in them, but what I asked for is the exact same number in the exact same position. And here we can see they've got the same fourth term, which is 19. So that's the slow way of doing it, writing out the list, finding if it is any point in there where they have the exact same number in the exact same position. The quick way of doing this is going, well, if these are my two sequences and there's a value where they're both the same, that means they have to have the exact same n value. Well, really, that's just solving when is 4n plus 3 equal to 2n plus 11. So we should be able to solve that. It's not too tricky. So 2n plus 3 is equal to 11. I'm running out of space. So take away 3 is 8, divide by 2, n is equal to 4. Now that tells me here they are exactly the same in the fourth term. And the question is, what value would that be? I'd have to substitute this in. It doesn't matter which one I substitute that into. I'm going to probably go for 2n plus 11 because that looks a little bit easier to me. 2 times 4 plus 11 is 19. So they are exactly the same in the fourth term, and that value is 19. So let's try that quick method here with the sequences 7n plus 1 and 3n plus 21. So 7n plus 1 is equal to 3n plus 21. So I would take away the 3n. I would take away the 1. I would get 4n is equal to 20. I did not leave myself enough space. So n equals 5. That means they're exactly the same in the fifth position. The fifth term is going to be exactly the same. Let's substitute that in. So let's do 3 times by 5. Add 21. So that's 15 add 21 equals 36. So they have the same fifth term. It is 36. Pretty quick and efficient. How about these two sequences? 5n plus 4 and 2n plus 1. So 5n plus 4 is equal to 2n plus 1. Well, I have to take away the 2n first to get 3n plus 4 is equal to 1. If I take away the 4, I get 3n is equal to negative 3, which means n is equal to negative 1. Now, this is an integer, but it's a negative number. And term positions, I can only have positive terms. So there's the first term, the second term, the third term, it keeps going, but they're always positive. So here, if it comes out as a negative number, then no, they never have the same number in the same position. Okay, last one. We've got 6n plus 2 is equal to 4n plus 11, and I've left myself even less space with this one. So let's take away 4n, and we get 2n plus 2 is equal to 11. If I take away the 2, I would get 2n is equal to 9. If Divide by 2 and I get n equals 4.5. Now, here's a decimal, and as we saw in the last video, can't have decimals for position numbers, for term positions, because they have to be positive integers. So again, no, they are never the same number in the same position.